we're going to be starting Lesson 93, Saxon Math, Course 3, Starred Problems. Now remember, we might not go all the way through to the final answer, but we're going to be showing you the method and any other steps you need to take to get to the answer. So, the first starred problem in Lesson 93 is problem number 3. Problem number 3 says the scale on a drawing is 1 to 24. If a building is drawn 10 inches wide, how many inches wide is it? Now, you're not given units in your scale, and if you're not given units in your scale, you have to assume that the scale is in the same units. So if the drawing is 10 inches, then the reality is going to be 24 times that many inches. So, if we're trying to find out how wide is it, we're going to say this is our x. We're trying to find how large is the building in reality. Now, we have our proportion set up. We've got the ratio of our scale, the ratio of the object itself, and we're going to look for a horizontal rule. 1 times some number is 10. 24 times that same number is going to give us the x value in inches. Now, I'm going to let you know, this one is going to be 10. 224 times 10 is going to be 240. Now, how many feet wide is this building? Well, we would take our 240 and we would use a unit multiplier. The unit multiplier to get inches into feet is 1 foot over 12 inches. So you're going to need to do this math here to find the number of feet. I will tell you, this 12 will cancel out with a 12 in 240. So try dividing 240 by 12. Then multiply by 1, cancel out your inches. I'll do that for you. You can cancel out your inches. And you need to know it's going to be 240 divided by 12. That'll give you your number of feet. Now, question number 4 is your next starred problem. Question number 4 says the vertices of a quadrilateral are at -2, -1, -1, -2, -1, 2, -1, 1, and 1, and -1, 1. Sketch it and its image after a dilation with a scale factor of 2. Alright, so I'm going to just use a gift card as a straight edge because I don't have my protractors from school. If you have a gift card, if you have your school ID, your photo card from lunch, all of these would be things that you could use as a straight edge. So right here, I've already pre-drawn the points. We've gone over graphing quite a few times. I will go through and label them as well, but we're going to work on the dilation mainly in this explanation. This is the quadrilateral we're talking about. This point here is the -2, -1. So I'm going to write that, -2, -1, right here. This one is 2, -1, 2 to the right and 1 down. This one is 1, 1. And this one is -1, 1. Now, as we're working through this, it says we have a dilation with a scale factor of 2. Now, the cool thing about scale factors and dilations when you're graphing is that all you have to do is multiply every coordinate by your scale factor. So, 1, 1 is the easiest example. 1, 1 times 2. Well, 1 times 2 is 2, and 2 times 1 is 2. So we're, instead of going to be at 1, 1, we're going to be at 2 over and 2 up. Now, -1, -1 times 2 is going to be -2, +2, up over here. Now, 2, -1, 2 times 2 is 4, -1 times 2 is -2. So we're going to go 4 to the right, 1, 2, 3, 4, and 2 down. And this -2 is going to be 4 to the left, and 2 down here. We're going to take our straight edge. Now, the second portion of this question is talking about the ratio of the areas from the dilation to the original. Now, the ratio of the areas, remember though, you might think, oh, I'm going to have to find the area of both of these shapes. That's going to be so much math. You don't. Remember that the ratio of the area is the scale factor squared. We're told the scale factor is 2, so the ratio of the area is 2 over 1 squared. Now 2 squared is 4, so it's 4 over 1, or 4 to 1 as our ratio. Very simple for that one. Question number 5 says, all real numbers greater than or equal to -1 and also less than 5. It asked us to graph this as an inequality on a number line. Now, greater than or equal to -1 means that we're going to have this symbol right here. Less than 5 is this symbol right here. We're going to have a closed dot on -1 and an open dot on 5. And now what I want to know is which numbers are both greater than -1 and less than 5. Now remember, greater than is going to go to the right, less than is going to go to the left. So which numbers would be both? Well, it'd be the ones in between them. So you would shade in the line in between them, make it nice and thick so that you can see that it's different from the line on the outside, and make sure I can see when you take a picture of your homework. For question number 6, what is the probability of drawing an A, E, I, O, or U expressed as a decimal? Now, the question before it gave this prompt said that you're drawing from a deck of alphabet cards that doesn't have an X. Now, usually the alphabet has 26 letters, but if we take out the X, it only has 25. So all we need to do is count up what we want and put it over what we have. Now, we have 25 cards left. There are 26 in the alphabet minus the X that's not there. Now, we want an A, an E, an I, an O, or a U. Now, that's 1, 2, 3, 4, 5 possible options. Now, 5/25 is 1/5, but the question asks us to express this as a decimal. You should know what decimal is 1/5. If you don't know what decimal is 1/5, do some quick math and figure out how many times does 5 go into 1. It's going to be 0 point something. It's going to look like this. B says if we draw one of the 5 vowel cards but do not replace, what is the probability of drawing one of the 4 remaining vowels in the deck in the next draw? So, we found that finding one vowel was 5 out of 25. We're saying we did that. We took one out. Let's say we took out the A. What's the probability, now that we've taken out the A, of an E, an I, an O, or a U? Well, there are 4 options that we want left, right? And you might say, oh, well, that's easy. It's going to be 4/25. It's not 4/25. You might be a little bit confused by that, but remember, we had 25 because we were missing an X. If we took out one of the vowels, the A, the E, the I, the O, or the U, then we've taken out one more card. So we've lost one vowel, and we've lost one card as our total. So it's going to be 4/24. Now, this fraction does reduce, and this one did want us to express it as a fraction. If you can figure out what this reduces to, that'll be your answer for B. Now, question 8 says the set of even counting numbers is 2, 4, 6, 8. The set of odd counting numbers is 1, 3, 5, 7, and so on. What's the intersection of these two sets? In other words, what do they have in common? Well, that one's a little bit tricky. Do they have anything in common? If we look at the two, is there any even number that's also an odd number? Is there any odd number that's also an even? No. Even and odd numbers divide the numbers into 2 sets. There are not any number that is both. We don't have any numbers that are oddly even. We don't have any numbers that are evenly odd. We just have even numbers and odd numbers. None of them are in both. There's a special set that we use to represent that. It's called the empty set, meaning that there is nothing that they have in common. I want you to look back at your notes from the week before we went off of school and remember, what's the symbol for an empty set? What's the symbol for an empty set? Write that symbol next to empty set in your answer. I'm expecting to see the symbol. Write the symbol. Union of these sets. That's what's in either of them. One or both. So if we're looking for one, the other, or both, well, that would be 1, 2, 3, 4, and so on. It would be all of our natural numbers, or counting numbers. Put the symbol for counting numbers in your answer for this one as well. Do your best. I know that it's a little bit difficult to draw those fancier letters, but find the symbol for the counting or natural numbers and put that in your answer for 8B. Now, 15 looks like it's going to be a lot of work. It's not that bad, trust me. Now, starting off, we're asked to simplify this. And I know this looks like it starts off by getting much more complex. But as you can see towards the end of my work, it's going to become much more simple. So, going through 12. What two square roots can we break 12 into, where 12 is broken into a perfect square and not a perfect square? Well, there's only one perfect square in 12, and it's 4. So we're going to have root 4 and root 3. What about 75? Well, 75 is a multiple of 25. 25 is a perfect square, so we're going to say that 25 will show up here, and 3 will show up here. Now, here, we're going to say that the square root of root 4 is 2, so we'll have 2 root 3. Square root of 25 is 5 root 3. Now, 2 times 2 is 4 root 3, and 4 times 5 is 20, and we're going to leave the root 3 alone. Now, remember that I've told you that if we have radicals with the exact same index, meaning they're a square root or a cube root, but not one or the other, it's the same, these are both square roots, and the same number inside of them, these are both 3's, we can treat them like a variable, and so these are like terms. So 4 plus 20, root 3. So whatever 4 plus 20 is, that's going to be your answer. I'll just give you this one, it's 24. So we're going to have 24 root 3 as our answer for 15. 16. Well, starting off, our variables are not isolated. We're going to need to isolate the variable, and they're not on the same side either. So what I'm going to do first is I'm going to add 2x to both sides. Now, that may seem silly because there's 2 x's here and only 1 x here, but this one's negative, so I'm going to get rid of the negative. That will give me negative 4, because negative 2x plus 2x is 0, is greater than or equal to 3x plus 5. And then I'm going to subtract 5 from both sides, which will give me negative 9 is greater than or equal to 3x. I'm going to divide both sides by 3, and that will give me negative 3 is greater than or equal to x. Now remember, negative 3 is greater than or equal to x means that x is less than or equal to negative 3. You need to remember what kind of dot will this have? What direction will a less than go in? Graph it on a number line. 17 says, graph these equations to find the solution to the system of equations. Now, both of these equations are in standard form, so we can use our graphing by intercepts rules. We can plug in a 0 for x, a 0 for y. I'm going to do the left-hand side over here. We're going to have 0 plus 2y equals 4. I'll divide both sides by 2, which means y will equal 2. If we have x plus 2 times 0 equals 4, then x will equal 4. So when x is 0, y is 2. When y is 0, x is 4. So we have the points 0, 2, which means we're going to go up 2 and over 0. And we have the point 4, 0. Now 4, 0 means we're going to go over 4 to the right. And we're not going to go up at all. I'm going to draw that equation. Now, I'm going to switch over to a different color of ink so we can see that it's a different line. We have x minus y is equal to 1. Now, if x is 0, then negative y equals 1, and we can divide both sides by negative 1, so y will equal negative 1. If we have x minus 0 equals 1, then x will just equal 1. So, our 2 points for this equation are 0 to the left and right and down 1, and 1 to the right and not moving up or down at all. So we're going to draw this line here. And we can see that our lines cross at this point here, this point being 2, 1. That means 2, 1 is the answer, our solution, to the system of equations. It's the point that is on both lines. It's the values that make both equations true. Now we have area equals 6s squared being solved for s. Now, first off, we need to handle the multiplication. We need to divide both sides by 6. That will give us a over 6 equals s squared. Now, how do we solve for s? Well, we have to take the square root of both sides. That will give us s equals plus or minus the square root of a over 6. And then we're done with that one. Now, question 21 says a cube has a surface area of 600 centimeters squared. What is the area of each face? Well, the surface area is equal to 6 times the area of each face. So we're going to set up 600 equals 6 times a. So if we divide both sides by 6, the surface area of one face is 100. What's the side length? Well, we just found area, so we can say 100 equals side length squared. To find side length, we're going to take the square root of both sides, and since it's a shape, we're going to say that it's just 10. We are not going to say plus or minus 10 because side lengths cannot be negative. Now, we're going to take that side length and we're going to put it in right here to find the volume. This will equal 10 times 10 times 10. And it'll be in centimeters cubed. So go ahead and find the volume. You can work through the rest of this yourself. 25. 25 talks about a catcher throwing a ball to a second baseman. Now, we are given information about the baseball diamond. I've flipped it on its side so you can see that this is a right triangle. It's an isosceles right triangle, so it is a 45, 45, 90 right triangle. Now, you could use the Pythagorean theorem, or you could recognize that C is going to be 90 root 2. It's going to be 90 root 2 because the hypotenuse is always side length root 2 if it's an isosceles right triangle. Now, it wanted us to estimate which option is closest to 90 root 2. Where it's a multiple choice question, so we should multiply out. Now, since we're in the 10th place, we skipped our digit. We started with a 0. Now, we're going to start off by multiplying by 9. Alright, so 9 times 4 is going to be 36. 9 times 1 is 9, plus 1 is 12. 9 times 4 is 36, plus 1 is going to be 7 with a 3. 9 times 1 is going to be, again, 12. Now we have to go 1, 2, 3 decimal places over, so it's about 127 feet. You need to have the multiple choice answer that goes along with that amount. Alrighty, that has been your star problems for the day. Stay safe, wash your hands, and do the rest of your homework. Don't just turn in the starred problems.